Hello, today we are going to solve one question from IIT JAM Biotechnology 2019. As we know that JAM is one of the most important examination in our country for those students who want to join IITs to pursue their master degree courses. Okay, so this is the question number 38 from section B. So it is a MSQ type question. That means more than one options can be correct among these given four options. So here we are given four statements and we need to find whether the statements are true or false. Okay. So the first statement is in intrinsic semiconductor, the number of electrons is equal to the number of holes at any temperature. An intrinsic semiconductor changes to an n-type semiconductor upon addition of a trivalent element. The third one is the shape of the 1,5 characteristic of a PN diode is a straight line, and lastly, in the reverse bias condition of current in a PN diode is due to the minority carriers. So here option A and option D are correct because an intrinsic pure semiconductor also called an undoped semiconductor or I-type semiconductor or I-type semiconductor is a pure semiconductor without any significant dopant species present. Is a pure semiconductor without any dopant species present. The number of charge carriers is therefore determined by the properties of the material itself instead of the amount of impurities. Okay. In intrinsic semiconductors, the number of excited electrons and the number of holes are equal. Therefore, N is equals to P. This may even be the case after doping the semiconductor though only if it is doped with both donors and acceptors equally. Both donors and acceptors equally. Okay. When a diode is connected in a reverse bias condition, when a diode is connected in a reverse bias condition, a positive voltage is applied to the n-type material. A positive voltage is applied to the n-type material, and a negative voltage is applied to the p-type material, and the negative voltage is applied to the p-type material. The positive voltage applied to the n-type material attracts electron towards the positive electrode. The positive voltage applied to the n-type material attracts electrons towards the positive electrode and away from the junction. While the holes in the p-type end are also attracted away from the junction towards the negative electrode. From the junction towards the negative electrode. The net result is that the depletion layer grows wide. The net result is that the depletion layer grows wider due to lack of electrons. Okay, lack of electrons and holes and presents a high impedance path. Almost an insulator, right? And The result is that a high potential barrier is created, thus preventing current from flowing through the semiconductor material. A high potential barrier is created, thus preventing current from flowing through the semiconductor material. Okay, so we have successfully answered this question, and that's all for today. Thank you very much.